Hello, my name is Irfan and I'm Marifan and I'm presenting about project background. Aquas Geoconsults and Environment, which is our company, has been asked to conduct an examination on the land in order to determine whether or not it is suitable for the construction of a one-story house there. This project can be found in Hulu Langat area of Selangor, which is in Malaysia. An investigation of the site carried out in order to collect geotechnical engineering data concerning the area beneath the site. This data is then used to provide information for the design, evaluation, and subsequent construction of the proposed structural foundation. Our objective is to design of a safe and sound foundation for the structure, to justify the type of foundation for this project, to determine if any small improvements operations are required during foundation building, and to justify the design consideration, settlement of the site project and bearing capacity. For site location, the location of the project is in Hulu Langat, which is in the Baranang, Selangor, Darul Ehsan. The diagram below depicts the construction project that is being proposed. The city of Baranang can be found 35 kilometers south of Kuala Lumpur, 13 kilometers south of Kajang, and 30 kilometers north of Seremban. About 3,000 people call this place home. It can be found on the boundary between states of Selangor and Negeri Sembilan.
Hi, my name is Nur Shamini and I will continue with the soil analysis. In this project, inclusive and cohesionless soil standard penetration tests were performed at 1.5 meter depth intervals using a 63.64 kg self-stripping hammer that dropped freely from the height of 76.2 cm. A speed spruce with a diameter of 50.8 mm was hammered into the ground. The first 150 mm's number of blows were counted for reference, and the subsequent 300 mm were based on the blow counts of the soil strata that were met, which show the relative density of non-cohesive soil and consistency of cohesive soil. When 50 consecutive SPT measurements exceed 50 or when 5 consecutive SPT measurements surpass 30, if the borehole depth exceeds 60 meters, drilling should be stopped. This is the result of the standard penetration test of the borehole. From the soil properties that we obtained from the bore log, this is the soil profile of the borehole. By using a suitable software and the structural drawing that we propose, this is the loads of every column that we will be used for the design the foundation. The minimum load is from column 1, which is 85 kN, while the maximum load is from column 12, which is 258 kN.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shamini binti Muhammad Sipri, metric number AF190113. So next, I will present for design of foundation. In our project, we use Meyerhoff approach to design the shallow of foundation. The design factor of safety that we use is 3. The allowable load for each group is calculated using the specified value for depth of foundation, the maximum load, and the area of foundation. There are 3 groups of column, and the allowable load is computed and compared to the total load using Meyerhoff approach to see if the shallow foundation can carry the load or not. This is one of the example for calculation of shallow foundation. The maximum load for group A is 99 kN. So our group has purpose a size of 0.8 meter times 0.8 meter times 0.5 meter. By using Meyerhoff equation of bearing capacity, we need to calculate the shape factor, depth factor, and incline factor. After we calculate the factor, we can get the ultimate bearing capacity as 781 kN per meter square. Then to get the allowable bearing capacity, the ultimate bearing capacity is divided by factor of safety, so we get 260 kN per meter square. Lastly, to get the allowable load is by multiply the allowable bearing capacity with the area of foundation. Hence, the size of shallow foundation purpose has an allowable load of 167 kN which is adequate to sustain the maximum load for Group A.
My name is Nora Ashra Farah binti Mat Azali and my metric number is AF190N060. I'll proceed with the design settlement. And categories that the settlement study of a shallow foundation can be categorized into. The first category is elastic or immediate settlement. The elastic settlement of a shallow foundation that happen either during construction or right away after. And the second one is consolidation settlement. Consolidation happens gradually when clay soils are saturated with water and submerged in it. Pore water is extruded from the empty spaces, where the sum of an elastic settlement plus a consolidation settlement is the entire settlement of a foundation. In addition, consolidation settlement has two phases, which is main and secondary. Then, for this project, we are using the elastic settlement. The settlement checking calculation are based on the column that experience the maximum load. The value of settlement for column 4, 11, and 12 are 53.90 mm, 61.90 mm, and 91.00 mm respectively. This is based on a study for shallow foundations. Based on this project, all foundations analyzed of the settlement of shallow foundation fall within the allowable range, which is 10% of the foundation width, and the superstructure above the soil can therefore be supported by the shallow foundations. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulaikha Aish binti Muhammad, AF19110. I will explain about the drawing for our project. Okay, this one is the ground floor structure for our project, which is we use a small house as our project. Okay. The next one is the section S1 for our project. This one is the roof plan for our project. And this one is the elevation A, B, C, and also D for our small house project.